अस्सलाम वालेकुम। लेक्चर नंबर 15 लेकर डॉक्टर मोहम्मद तजम्मुल चुगताई हाजिर है। आज के लेक्चर में हम गुज़श्ता लेक्चर से ही आगे कुछ मैश टेक्निक्स का एनालिसिस सीखेंगे। इन मिसालों में हम आज देखेंगे कुछ सादा किस्म की मैश एनालिसिस, उसके बाद हम कुछ एडवांस मैश एनालिसिस से मुतल्लिक प्रॉब्लम्स का सलूशन ढूंढेंगे। सबसे पहले जो हम मिसाल हल करने जा रहे हैं उसमें एक रेजिस्टिव नेटवर्क को लिया गया है। इस रेजिस्टिव नेटवर्क में हर रेजिस्टेंस के अक्रॉस वोल्टेज ड्रॉप को पहले से ही मुहैया कर दिया गया है और हमने मुख्तलिफ पॉइंट्स के दरमियान वोल्टेज के लेवल को कैलकुलेट करना है। इससे मिलती जुलती मिसाल हम पिछले लेक्चर में कर चुके हैं, लेकिन फ़र्क सिर्फ ये है कि इस मिसाल में तमाम रेजिस्टेंसेस के अक्रॉस वोल्टेज ड्रॉप की वैल्यू को दिया गया है, जबकि उस मिसाल में वोल्टेज ड्रॉप्स मुहैया नहीं किए गए थे। आइए स्लाइड पर पहली मिसाल को देखते हैं। The slide shows a resistive network consisting of 3 resistances and an independent voltage source having a value of 12 volts. We want to calculate the voltages between the points A, D and A, C. Now obviously you can see that these values which are desired to be calculated, they are not the ordinary values as we have been doing earlier on, that we wanted to calculate between the reference point and one of the points. These are just among the 2 points. Now, if you see onto the slide, we have marked this circuit with points A, B, C and D. Now starting from A, we can see that the first resistance has been provided with a voltage drop across it having a value of 6 volts. The resistance which is next to that and is attached between the point B and C has a voltage drop value of 4 volts across it, whereas the last resistance which is between the points C and D have been marked as having a voltage drop value of 2 volts across it. Now, looking upon the desired voltage levels which have been asked into the question, we can draw the imaginary lines between the point A and D, the points A and C. Now, these imaginary lines or arrows, we can consider them as they are having connected an imaginary voltage level in between them, and these voltage levels as shown in this slide have been marked as accordingly VAC, VAD. Now, we can clearly see that the point A has been directly attached to the positive terminal of the 12 volt source. Also, we can observe that the point D has been directly connected as well to the negative terminal of the 12 volt source or the 12 volt battery. Therefore, clearly we can see that the value of the desired voltage, which is one of the voltage levels asked into the question VAD, can be declared as 12 volts. Now, there is no physical closed path between points A and C. We can consider 2 closed paths ACBA and ACDA. Now, as we have mentioned, these 2 closed paths इनसे हम देख सकते हैं कि स्टार्टिंग फ्रॉम द पॉइंट ए किस तरह से किसी भी एक लूप को कंसिडर करते हुए हम अपनी लूप इक्वेशन या KVL इक्वेशन को लिख सकते हैं। इसमें कोई फर्क नहीं पड़ेगा कि हम एक लूप लें या उसके दूसरा रास्ता इख्तियार करें, जवाब एक ही आएगा। आइए इसकी फर्दर ट्रीटमेंट को देखते हैं। Now, if we apply KVL equation for the path AC, B and A, obviously as we have been doing for the mesh analysis, that we choose one point to start from and proceed towards the last point and come back to the initial point. Let's start from the point A. Starting from the point A and moving towards the point C, we can see that there is an imaginative voltage source which has been marked as VAC. Therefore, we can write plus VAC. We have considered that the terminal of the voltage source VAC, which is towards the point A, bears a positive sign. Now, after writing this, we move forward to the point C. And from point C, because we have already chosen the path A, C, B and A, therefore, from point C, we will be moving towards the point B. As we are standing onto the point C and looking onto the point B, we can see there is a resistance in between the point C and B, and the terminal of the resistance, which is towards the point C, that has been marked as a negative. Therefore, we will write minus there, and the voltage drop across this resistance has been given as 4 volts. Therefore, we write next to that negative sign 4. And we go through this circuit element and reach at point B. Now, reaching at point B, we will be facing towards the point A. And we can also see that a resistive element also exists between the point B and A. This resistive element has been provided with a value of 6 volts across it, and also the terminal of this resistance, which is towards the point B, has been marked as negative. Therefore, we put a negative sign, and next to that we will write the voltage drop across this resistance, which is 6. After crossing this resistance, we reach back at the point A. अब जबकि हम पॉइंट ए पर वापस पहुंच चुके हैं और हमारे बुनियादी मैश एनालिसिस या फिर लूप एनालिसिस की शर्त के मुताबिक किसी भी सर्किट का कोई भी एलिमेंट एक से ज़ायद मरतबा रिपीट नहीं किया जा सकता, लिहाजा हमें यहाँ पर स्टॉप करना होगा और हमने जो एक्सप्रेशन लिखा है उसको हम इक्वेट करेंगे 0 के बराबर। आइए इस सर्किट की फर्दर ट्रीटमेंट को एक मरतबा फिर स्लाइड पर देखते हैं। So, we equate this expression, which is VAC minus 4 minus 6 equals 0. And if we rearrange this expression, we end up with VAC having a value of 10 volts. अजीज तलबा, जैसा कि हमने पहले आपको बताया कि दोनों लूप में से कोई एक भी लूप लेकर हम एनालिसिस करें तो जवाब एक ही आएगा। अब जबकि हमने लूप ए सी बी और ए लेकर VAC की वैल्यू को कैलकुलेट कर लिया है और हम जानते हैं कि इसका जवाब 10 वोल्ट्स आया है, आपके एक्सपीरियंस के लिए हम दूसरी लूप का एनालिसिस बी लेंगे, यानी दूसरी लूप ए सी डी और ए होगी। और इसका जवाब भी 10 वोल्ट ही आना चाहिए। आइए इस प्रोसेस को स्लाइड पर देखते हैं। Taking second path, which is A, C, D and A, and we apply KVL to this loop so that we can write, starting from the point A going towards the point C, we encounter once again the imaginative VAC voltage source. Therefore, we write plus VAC. Plus sign depicts that the terminal which is towards the point A has been considered as a positive terminal. Next, we go through this VAC source and reach at the point C. Now, because we are going to take the path ACDA, therefore, standing at the point C, we will be facing towards the point D. Once again, we encounter a resistance in between the point C and D. Also, the voltage drop given across this resistance has been marked as 2 volts, and the terminal of the resistance which is towards the point C has been marked as positive. Therefore, after writing VAC, we write plus 2. And we go through this resistance and reach at the point D. After reaching at the point D, once again we will be facing towards the point A. However, we encounter another voltage source in between the point D and point A, and that voltage source has been given a value of 12 volts. Also, the terminal of the voltage source which is towards the point D, that is negative. Therefore, we will write VAC plus 2 minus 12 equals 0. Now, rearranging this equation, once again we end up with the same result as we have been calculating into the previous slide, that is VAC is equal to 10 volts. अजीज़ तलबा, इस मिसाल में आपने देखा कि एक वोल्टेज जो कि हमें क्वेश्चन में रिक्वायर्ड थी वो डायरेक्टली एक वोल्टेज सोर्स के अक्रॉस पूछी गई थी, लिहाजा उसको कैलकुलेट करने की कोई ज़रूरत ना थी, इसलिए हमने डायरेक्टली उसकी वैल्यू को ही उस वैल्यू के बराबर रख के उस जो कि उस वोल्टेज सोर्स की वैल्यू थी उसको बता दिया। दूसरे केसेस में जो कि 2 अदर वोल्टेजेस हमसे डिमांड की गई थी, उसमें हमने देखा कि किस तरह से एक इमेजिनेटिव वोल्टेज सोर्स को कंसिडर करके एक लूप को लेकर उस इमेजिनेटिव वोल्टेज सोर्स को कैलकुलेट किया गया, और फिर ये भी कंपैरिजन आपने देखा कि अगर हम अल्टरनेटिव लूप को ले लें तो फिर भी जवाब वही आता है। इसकी मज़ीद मिसालें आप अपनी टेक्स्ट बुक में लेकर उनको प्रैक्टिस कर सकते हैं। अजीज़ तलबा, इससे अगली मिसाल इस मिसाल से मिलती जुलती है, फ़र्क सिर्फ इतना है कि अगली मिसाल में हमने 2 वोल्टेज सोर्सेज जो कि इंडिपेंडेंट वोल्टेज सोर्सेज हैं उनको रेजिस्टिव नेटवर्क में इस्तेमाल किया गया है, और तमाम रेजिस्टेंसेस के अक्रॉस एक मरतबा फिर वोल्टेज ड्रॉप्स की वैल्यूज़ को मुहैया कर दिया गया है। आइए स्लाइड पर इस मिसाल को देखते हैं। स्लाइड शोज अ सर्किट consisting of 2 voltage sources, each having a value of 6 and 12 volts. There are only 2 resistances which have been used into this circuit. The top resistance have been marked with a voltage drop of 10 volts across it, whereas the bottom resistance has been marked as having a voltage drop across it as 8 volts. Now, We have also marked the various points or the nodes for this circuit as A, B, C and D. We want to calculate the values of VAC, the voltage difference which will appear between the point A and the point C. Also we want to calculate VDB, that is once again the potential difference which will appear for this circuit between the points B and D. Now, looking upon these voltages, if we draw our imaginative voltage sources, then the circuit will look like this. We join the points A and C. Also, we join the points B and D. However, we mark the respective imaginative voltages in between these 2 points so that we can calculate these values. And we consider that these voltage sources are having those values which have been asked into the question. Once again, if we consider the voltage VAC, we can also see 2 paths for it to calculate. The first path may be A, C, D and back to A, and the other path may be A, C, B and A. Now, if we apply the Kirchhoff's voltage law to the loop A, C, D and A, once again we can easily write our equation as, starting from the point A and going towards the point C, once again we have imaginative voltage source VAC in between. Also, we consider that the terminal of VAC, which is towards the point A, is positive. Now, we have considered it as positive because it is directly attached to the higher level of the voltage source having a value of 12 volts. Therefore, we can write plus VAC. We go through this imaginative circuit element and reach at the point C. Now, because we have already decided to follow the path A, C, D and A, therefore, when we reach at the point C, we will be looking towards the point D. Looking on to the point D, we see that there exists a resistive element between the point C and point D. Also, this resistive element has been marked with the voltage drop across it having a value of 8 volts, and the terminal of this resistance, which is towards the point C, has been marked as positive. Therefore, after VAC we will write plus 8. After writing this, we go through this resistive element to reach at the point D. After reaching at the point D, we will be looking towards the point A, and once again we encounter a 12 volt voltage source in between the points A and D. Also, we can see that the negative terminal of this voltage source has been attached to the point D. Therefore, while looking towards point A from the point D, we can see a negative sign. Therefore, we will write minus and the value of this voltage source, which is 12, and equate all this to 0. Simplifying this expression, we can have VAC is equal to 4 volts. अब जबकि हमने पाथ A, C, D, A को लेते हुए VAC की वैल्यू को कैलकुलेट कर लिया है, लिहाजा हम अल्टरनेटिव मैश को कंसिडर करते हुए एक मरतबा फिर जैसा कि हमने पिछली मिसाल में किया था VAC की वैल्यू को कैलकुलेट करने की कोशिश करेंगे और इस केस में भी दोनों जवाबात एक दूसरे के बराबर ही आएंगे। ये प्रैक्टिस सिर्फ इसलिए करवाई जा रही है ताकि आप एग्जामिनेशन में कंफ्यूज ना हो या फिर कभी प्रैक्टिकल लाइफ में आप कंफ्यूज ना हो। किसी भी रूट को इख्तियार करते हुए आप कैलकुलेशंस कर सकते हैं और घबराने की ज़रूरत नहीं है, किसी भी रूट को लेते हुए जवाब सेम ही आएगा। आइए दूसरा अल्टरनेटिव रूट लेते हुए हम एक मरतबा फिर VAC की वैल्यू को कैलकुलेट करते हैं। Now we take the root ACBA to calculate the value of VAC. Once again, we start from the point A. Standing at the point A and looking towards the point C, we encounter VAC in between these 2 points. Therefore, we write VAC with a positive sign next to it. We go through this imaginative circuit element and reach at the point C. Once we reach at the point C, and because in this case we have decided to follow the path A, C, B and A, therefore, we will be looking towards the point B. While looking towards the point B, we see that there exists an independent voltage source between the point B and C, and that voltage source is having a value of 6 volts. The point C has been attached to the positive terminal of the voltage source. Therefore, we will write plus 6. We go through this circuit element which is independent voltage source and reach at the point B. Once we reach at the point B, we will be looking towards the point A, and in fact this is the only way you can look into. While looking on to the point A, we see that there is an other resistive element in between the point A and B. This resistance has been marked as having a voltage drop across it. A value for that drop is 10 volts, and the terminal of this resistance which is towards the point B is negative. Therefore, we will write minus 10 and we reach at the point A which is our starting point. Therefore, we equate all this to 0. Simplifying it, we can find VAC is equal to 4 volts. अजीज तलबा, एक मरतबा फिर हमने देखा कि कोई भी लूप लेते हुए उसके अल्टरनेटिव पाथ्स को कंसिडर करें और किसी एक वोल्टेज को कैलकुलेट करें तो किसी भी रास्ता को इख्तियार करते हुए उसका जवाब एक ही आएगा। आइए अब दूसरी रिक्वायर्ड वोल्टेज जो कि हमें क्वेश्चन में एट द बिगनिंग पूछा गया था उसको स्लाइड पर कैलकुलेट करते हैं। To find out the voltage VBD, we also can see that there are 2 paths, and these paths are BDCB and BDAB. If we consider the path BDCB first, and we start writing the KVL equation from the point B for this mesh, Starting from the point B and looking towards the point D, we can see that once again there is a imaginative voltage source VBD. Therefore, we will write minus VBD. After reaching at the point D, we will be facing towards the point C, and we can see that there exists a resistance between the points C and D, and the voltage drop across this resistance has been given as 8 volts. Also, the terminal towards the point D has been marked as negative. Therefore, we will write minus 8. We go through this resistance and reach at the point C. While we are at the point C, we will be facing towards the point B, and in between the points C and B, we can see that there exists a 6 volt voltage source, and the positive terminal of this voltage source has been connected to the point C. Therefore, we will write plus 6. And now, because we have reached at the point B, which was our starting point, therefore, we have to stop writing the equation any further and equate this whatever we have written to 0. Simplifying it, we can have a value of minus VBD is equal to 2 volts. Now, once again, VBD is equal to minus 2 volts, and if we reverse the sequence of these voltages, that is, we write VDB, then obviously we have to write equals 2 volts. Now, once again, we take the alternative mesh and apply the KVL rule to this alternative mesh. Therefore, once again, starting from the point B and looking towards the point D, we can see that there exists an imaginative voltage source which has been marked as VBD. Therefore, we write minus VBD. As we reach at the point D, we will be looking towards the point A because we are following the alternative mesh. Looking towards the point A, we can see that there is once again a voltage source attached between the point A and D, and that voltage source has been marked as having a value of 12 volts. And because the negative terminal of this voltage source has been attached to the point D, therefore, we will write minus 12. We go through this voltage source and reach at the point A. After reaching at the point A, we will be facing towards the point B. And also, we can see that there is a resistance between the points A and B. The voltage drop across this resistance has been given as 10 volts, whereas the terminal which is towards the point A has been marked as plus. Therefore, we will write plus and the value of the voltage drop across the resistance, which is 10. After writing plus 10, we go through this resistance element to reach at the point B, which is once again our starting point. After reaching at the point B, we can equate all this expression to 0. Simplifying it, we write minus VBD is equal to 2 volts, or once again we can write VBD is equal to minus 2 volts, or once again we can write the expression for the voltage other way round, that is VDB, and that will be equal to 2 volts. अजीज तलबा, अभी तक हमने मैश एनालिसिस में सादा तरीन मिसालें देखी, जबकि इनमें किसी भी 2 पॉइंट्स के दरमियान पोटेंशियल डिफरेंस को कैलकुलेट करना बताया गया था। आइंदा मिसालों में हम थोड़ा सा एडवांस मैश एनालिसिस सीखेंगे, जिसमें 2 या उससे ज़्यादा लूप्स गिवन होंगी और उनमें मुख्तलिफ़ किस्म के सोर्सेस भी इस्तेमाल किए गए होंगे। इन लूप्स को अलहदा से, जिस तरह से मैंने पिछले लेक्चर में एक मिसाल बताई थी जो कि 2 लूप्स पर मुश्तमिल थी, कंसिडर करके उनकी KVL इक्वेशंस लिखेंगे और फिर इन KVL इक्वेशंस को सॉल्व करते हुए हम मुख्तलिफ अननोन वैल्यूज़ को कैलकुलेट करना सीखेंगे। अगली मिसाल में 2 लूप्स का एक रेजिस्टिव नेटवर्क दिखाया गया है, जिसमें एक करंट सोर्स और एक वोल्टेज सोर्स इस्तेमाल की गई है। अगर तो किसी लूप में कोई करंट सोर्स अटैच हुई हो तो उस लूप में से पास होने वाले करंट को उस वोल्टेज सोर्स के करंट के बराबर ही कंसिडर कर लिया जाएगा, जबकि अगर किसी लूप में कोई करंट सोर्स अटैच ना हो तो उसमें फिर हमें एक पास होने वाले करंट की वैल्यू इन टर्म्स ऑफ I1 या I2 व्हाटएवर सुइटेबल कंसिडर करना होगी और उसको लेकर हम आगे मुख्तलिफ कैलकुलेशंस करेंगे। आइए इस चीज़ की प्रैक्टिस स्लाइड पर दी गई मिसाल से करते हैं। स्लाइड शोज a resistive network having 2 meshes. We give the name mesh 1 to the mesh which is on our left hand side, and we consider the right hand side mesh as mesh 2, and we want to calculate the voltage V0 at the output terminals of this circuit. Now this circuit has also used 2 sources. One of them is independent voltage source having a value of 12 volts, and the other is an independent current source having a value of 2 milliamperes. Now we also consider that the current passing through the mesh 1 is I1, and it is passing through the whole mesh in the clockwise direction. For the mesh 2, we also have shown the path of the current passing through this mesh, and coincidentally this is the same path which is been used into the current source. We name this current as I2, and now because there is one current source which is attached into the mesh 2, therefore we can simply write as I2 is equal to 2 milliamperes, which is the value of the current source attached into the mesh 2. आप भी हैरान हो रहे होंगे कि इससे पिछली मिसाल में हमने वोल्टेजेस को कंसिडर किया था, जबकि इस मिसाल में हम करंट्स को कंसिडर कर रहे हैं। इसकी बुनियादी वजह यही है कि पहली मिसाल में हमें वोल्टेज ड्रॉप्स की वैल्यूज़ गिवन थी, जबकि रेजिस्टेंस और करंट्स की वैल्यू नामालूम थी, जबकि इस मिसाल में हमें रेजिस्टेंस की वैल्यूज़ नोन हैं, जबकि वोल्टेज ड्रॉप्स की वैल्यूज़ नहीं दी गई। लिहाजा हम एक करंट को किसी भी मैश में से फ्लो करते हुए कंसिडर करके वोल्टेज की वैल्यू को निकालने की कोशिश करेंगे। एक बात और ज़हन नशीन रखिए कि जब मैश 1 में हमने कंसिडर किया कि करंट क्लॉकवाइज जा रहा है, तो मैश 2 में भी हमने इसकी कन्वेंशनल करंट की डायरेक्शन को क्लॉकवाइज ही कंसिडर किया है। अब जब हम इनकी बाउंड्री ब्रांच जो कि दोनों मैशेस के दरमियान में एक रेजिस्टेंस की सूरत में है, वहाँ पर दोनों को देखेंगे तो दोनों करंट अप टू सम एक्सटेंट एक दूसरे को कैंसल आउट करेंगे, क्योंकि दोनों की डायरेक्शन while passing through that branch will be opposite to each other. लिहाजा जब हम KVL इक्वेशन को लिखेंगे तो इस फैक्टर को लाजमी तौर पर मद्देनज़र रखा जाएगा। आइए इस सर्किट को एक मरतबा फिर देखते हैं और फिर इसकी KVL इक्वेशन लिखने की प्रैक्टिस करते हैं। The KVL equation for mesh 1 will be 3KI1. Now we have written 3KI1. That will mean that I am starting to write the KVL equation from the top left corner of the circuit. And because we have considered that current I1 is passing through the mesh 1, therefore, in terms of voltage using Ohm's law, we can write the voltage drop across 3 kilo ohm resistance as 3K into I1. Now, we pass through this resistance having a value of 3 kilo ohms, and we reach at the point which is marked with the letter V. Now, when we have reached at this point, we will be looking downwards and we see that there exists a 6 kilo ohm resistance. And because 3 kilo ohm and 6 kilo ohm resistance up to this mesh, they are in series to each other. Therefore, into the same direction, current I1 will be passing through the 6 kilo ohm resistance. However, we must have to take into account the current I2 which is passing through the mesh 2, because from this branch having a value of 6 kilo ohm, that current I2 will be going upwards and the current I1 is going downwards. Therefore, both the currents will be cancelling out each other. Hence, we write the value of this resistance, which is 6K, into the difference of these two currents. That is, we write I1 minus I2. After writing this, we reach across the 6 kilo ohm resistance and we are at the bottom of the circuit. And because we have to close down the mesh, therefore, we will be looking towards the 12 volt source, and we can also see that the negative terminal of this 12 volt source has been attached to that point. Therefore, either we can write minus 12 equals 0, or in this case we have written the whole expression equal to 12. Now, simplifying this expression, we can write 9K I1 minus 6K I2 is equal to 12. Or further simplifying it, we can write 9K I1 minus 12, that is, this minus 12 has been calculated by putting the value of 2 milliamperes. So, the milli factor has been cancelled out with the kilo factor, hence 6 into 2 we have minus 12 and equals to 12. Further simplifying it, we can write I1 is equal to 2.6 milliamperes. अब चूंकि हमने V नॉट को कैलकुलेट करना है और ये V नॉट करंट सोर्स के अक्रॉस मेजर की जाएगी, लेकिन इससे पहले एक 2 किलो ओम की रेजिस्टेंस भी अटैच्ड है, लिहाजा अगर हम उस रेजिस्टेंस के अक्रॉस वोल्टेज ड्रॉप को कैलकुलेट कर लें तो हमारे लिए V नॉट को कैलकुलेट करना निहायत आसान हो जाएगा। लिहाजा हम V जो कि सर्किट में पॉइंट मार्क किया गया है उसको कैलकुलेट करते हैं और फिर आगे फर्दर ट्रीटमेंट के ज़रिए V नॉट की वैल्यू को कैलकुलेट करेंगे। आइए स्लाइड पर देखते हैं। Now voltage across 6K resistance can be given as V is equal to 6K into I1 minus I2. That is once again that through 6K there are two currents which are flowing in opposite direction. Therefore, we can write, after putting the value of I1 and I2, V is equal to 6K into 8 divided by 3 minus 2. That will be equal to 4 volts. As current through 2K resistor is I2 is equal to 2 milliamperes. Therefore, the voltage across 2K resistance will be 2K into 2 milliamperes. That will be equal to 4 volts. Hence, for V naught we can write V naught is equal to V minus V at 2K. Therefore, we can write V naught is equal to 4 minus 4 is equal to 0 volts. अजीज तलबा, आपने देखा कि इस मिसाल में जो कि रिक्वायर्ड आउटपुट टर्मिनल्स के अक्रॉस हमने वोल्टेज निकाला वो 0 आ गया है, यानी कि इससे ये मतलब होगा कि दोनों टर्मिनल्स के अक्रॉस कोई भी पोटेंशियल डिफरेंस नहीं होगा। या दूसरे अल्फाज में इस तरह से समझ लें कि हो सकता है दोनों टर्मिनल्स किसी और वोल्टेज लेवल पर हों, लेकिन दोनों का वोल्टेज लेवल एक ही होगा। अजीज तलबा, आज के लेक्चर में हमने कुछ सादा मैश एनालिसिस और थोड़े से एडवांस मैश एनालिसिस टेक्निक को सीखा। अगले लेक्चर में हम मज़ीद एडवांस और कॉम्प्लिकेटेड किस्म के मैश एनालिसिस टेक्निक्स को सीखेंगे। इनमें मुख्तलिफ सोर्सेज यानी वोल्टेज और करंट सोर्सेज को इस्तेमाल किया जाएगा और 2 या उससे ज़्यादा मैशेस का एनालिसिस भी सीखा जाएगा। आज के लेक्चर का वक्त ख़त्म हुआ चाहता है। अगले लेक्चर तक के लिए इजाज़त दीजिए। अल्लाह हाफ़िज़।